Welcome to our online chemistry class. Myself, KHARGE from SSPMS and Junior College. Our today's topic is Introduction to Polymer Chemistry. In this topic, we have to discuss about addition and condensation polymers. In that, we have to discuss the mechanism of addition polymerization and some important polymers. Let us discuss chain growth polymerization or addition polymerization. Here, this addition polymerization can take place with the help of free radical mechanism. So, in the free radical mechanism, there are different steps. First is formation of free radical. It can produce by using initiator or catalyst. Second one is chain initiation. Then that free radical produced by using initiator produces a new radical when it combined with monomer. Then the next step one is chain propagation. That new radical produced in the chain initiation step react with another molecule of monomer to form bigger size radical. Then last step is the chain termination. It can be brought about by non-supplying the monomer or by addition of impurities like oxygen or by coupling of two growing chain radicals of that polymer. So let us discuss the free radical mechanism in detail with an example. So first step is formation of free radical. So catalyst or initiator, here benzoin peroxide is used as a catalyst or initiator. It generates the free radical by homolysis. So this is benzoyl peroxide. The bond between two oxygen atoms undergo cleavage in symmetrical manner, homolytic fashion, and each oxygen atom carrying one electron each, and we get two radicals of benzyl C6H5COO dot, because it contains odd number of electrons, that two electrons between oxygen atom get distributed to each oxygen, and again the bond between these two carbons, carbon of the ring and CO carbon, carbonyl carbon, undergo cleavage again in symmetrical manner, and C6H5 carrying one electron, CO carrying one electron, that combined with another electron from oxygen, and it will produce carbon dioxide. Here there is a formation of phenyl radical. So first initiator generate a free radical, and then that free radical combined with your monomer. Here ethene is the monomer, and it will give again this bond between two carbon undergo cleavage in symmetrical manner, and the one electron from that phenyl free radical combined with one electron from this carbon-carbon bond, and it will form a new bond between that phenyl carbon and CH2 carbon, while the another electron between carbon and carbon goes towards the another carbon or ending carbon, and it generates a new free radical of that monomer. So here chain initiation will take place. Then there is a propagation or elongation of chain, that monomer free radical combined with another molecule of monomer, second molecule of ethene, and again similar type of reaction will take place. The bond between two carbon undergo cleavage in symmetrical manner. The one electron from this bond between two CH2 carbon form a bond with this free radical carbon, and the one electron which is remain during this bond cleavage goes to another end of that CH2 carbon. So in this way chain get elongated or propagated. So this is the chain propagation. If we take n number of molecules of this ethene, then this dash CH2 group get repeated n times. So our chain becomes C6H5 CH2 n times dash CH2 dot. So in this way we can elongate the chain. How many number of CH2 group will require, on that basis we have to take n value, and at the end when we added sufficient molecules of that monomer, now last step is the ending of the chain, that is chain termination process. So here two free radicals of that monomers combine together and they form a long chain like this. CH2 C6H5 dash CH2 n times CH2 CH2 n times C6H5. So this chain initiation step and takes place with the help of different types non supplying the monomer. If you stop the supply of monomer, then there is ending of chain, or by adding some impurities like oxygen, or by coupling of two growing chain radicals of that polymer. So here this chain termination can take place with the help of last type. So this is the mechanism of free radical. Then we have to discuss some important polymers. First one is low density polymer LDP, that is polythene. Then high density polymers, that is HDP, again polythene. Then polytetrafluoroethylene PTFE, or it is also known as Teflon. The next type of polymer that we have to discuss is polyacrylonitrile, that is PAN or Orlon. Next one is the Nylon, then Terylene or dacron, then bakelite, it is a phenol formaldehyde polymer, then melamine formaldehyde polymer, and last one is the urea formaldehyde polymer. These are some important polymers that we have to discuss in this topic. So let us discuss first one, preparation of some addition type of polymers. So which are they? They are polythene LDP, polythene HDP. These are with high density and high melting points, and they are also known as coordination polymers. Then we have to discuss Teflon and PAN or Orlon in detail. Let us discuss one by one. So first one is preparation of some important addition polymers, polythene. Here we have to discuss first low density polymer, that is LDP. So it is obtained by polymerization of ethene under high pressure of near about 6 to 7 atmosphere at a temperature of 350 to 370 Kelvin in presence of a oxygen molecule or a peroxide. Here it is used as a catalyst. So there is a formation of low density, that is LDP polymer, and it is produced by free radical addition process. The hydrogen atom abstracted has high branch structure. Now what is the properties of this LDP? So LDP is chemically inert, tough but flexible, and it is a poor conductor of electricity. Then with the help of this property, it has some uses. It is used in the insulation of electricity carrying the wires, and manufacture of squeeze bottles, toys, and flexible pipes. So this reaction that we already learned. So if we take n molecules of ethene, it will give CH2 n times polythene. So reaction takes place at 350 to 370 Kelvin and at 6 to 7 atmospheric pressure. Here oxygen is added as an initiator. Very simple. So Remember this reaction and write the properties and uses. The next one is the high density polythene, that is HDP polymer. It is formed when addition polymerization of ethene takes place in a hydrocarbon solvent in presence of catalysts such as triethyl aluminum and titanium tetrachloride, that is also known as Ziegler-Natta catalyst, at a high temperature such as 333 to 343 Kelvin and under a pressure of 6 to 7 atmosphere. Okay, so here you can observe the reaction. The number of molecules of that ethene gives dash CH2 n times. Reactions are same but conditions are different. Here catalyst is Ziegler-Natta catalyst. In previous LDP process we use oxygen as initiator or catalyst. So which are the properties of this HDP? It consists of linear molecule and high density due to the close packing. It is chemically inert, it is more tough and hard. That's why it is used for manufacture of buckets, dustbin, bottles and pipes, etc. Okay, do not mix the properties and uses of this LDP and HDP. So write down the specific properties and uses when a particular polymer is asked. Next one is the Teflon polytetrafluoroethylene, that is nothing but Teflon. It is also denoted by PTFE. So Teflon is manufactured by heating tetrafluoroethene CF2 double bond CF2. It is chemically inert and resistant to attack by corrosive reagent. It is used in making the oil seals and gasket. It is also used for non-stick surface coated utensils. So what is the reaction? CF2 double bond CF2, that is tetrafluoroethene. If we take n number of molecules, it gives CF2 dash CF2 n times, that is Teflon polytetrafluoroethene, and here catalyst is used as a persulfate. Okay, then next one is the polyacrylonitrile or PAN or Orlon. It is also addition polymer, and the addition polymerization of this acrylonitrile, which is used as a monomer in presence of peroxide as a catalyst, that gives polyacrylonitrile PAN or Orlon. So what is the reaction? N molecules of CH2 double bond CHCN. So you can call this as a vinyl cyanide also. It undergo polymerization in presence of peroxide, and it will give that CN remain as a branch. So it is a branch chain polymer dash CH2 CN n times. So it is a polyacrylonitrile, and it is used as a substrate for wool in making the commercial fiber as Orlon or acrylane. Okay, then next one is step growth polymerization or condensation polymerization. Just now we see only addition polymer, monomers get only added, but in these polymers are formed by combination of two or monomers by elimination of simple molecule like water or methyl alcohol. So here monomer is used, which is bifunctional, means there are two groups which are functional groups at the end of that molecule. So in these reactions, the product formed in first step has again two functional groups to continue and grow the chain. That's why it It is called as step growth polymerization. Which are the examples of this type? Nylon, which is a polyamide fiber, or you can say another example as Terylene, which is a polyester fiber. So in nylon there is a amide linkage, that's why it is polyamide fiber, while in case of Terylene there is a ester linkage, that's why it is called as polyester fibers. So first one is nylons. So here we have to discuss first nylon 66. It is prepared by condensation polymerization. What is condensation? During the process, small molecule like water or methyl alcohol is removed as a byproduct. So here two monomers are taken. One is adipic acid COH CH2 4 times COH. Another monomer is hexamethylene tetramine, diamine. CH2 6 means hexa, CH2 group is methylene, NH2 group is called as amine. So it is hexamethylene diamine. When it is heated under high pressure and high temperature such as 553 Kelvin, then the OH from adipic acid and hydrogen from NH2 group of hexamethylene diamine get removed as a water, and there is a formation of bond between this C double bond O, that is carbonyl group of adipic acid, and NH of hexamethylene diamine. Okay, and that compound is called as nylon 66. So there are 6 CH2 groups in both these monomers, that's why the word is nylon 66. And that nylon word comes from New York and London. The scientist who prepared this polymer is from New York and London, that's why the word is given. The polymer nylon 66 has molecular mass near about 12,000 to 50,000 unit. Which are the properties of this nylon 66? It possesses high tensile strength and it does not soak the water, and that's why it is used in making the sheets, bristles for brushes, and in textile industry. So remember these properties. Short note may be asked. So next compound is nylon 6. It is obtained by heating the epsilon caprolactam with water at high temperature such as 533 to 543 Kelvin. So if you observe your monomer, it is single molecule, and here the numbering is present after CO, which is a functional group carbon. Next carbon is alpha, beta, gamma, then omega, and then epsilon. So that NH group is attached to this epsilon carbon, so it is a epsilon caprolactam. Then here the bond between NH and CO undergo broken, and this ring get open, so it is ring opening polymer, and there is a formation of a chain like structure dash CO CH2 5 times NH. So here only 6 carbon or 6 CH2 groups are present in the chain, and this group get repeated n times if you take n number of molecules. That's why the word is nylon 6, and it is used in manufacture of tire cords, fabrics, and ropes. Okay, so which are the properties of this? That's why it shows this uses. They are crystalline, insoluble in hydrocarbon solvent, having good tensile strength, and they take up bright colors and beautifuls. So it is used in making the brushes, scrubbers, saris, ropes, finishing nets, then shirts, bed covers, toys and paints, etc. So properties and uses are different, so you have to write correct properties and uses of that particular polymer. Next one is the polyester or dacron or terylene. If you observe the nylon fibers, they are polyamide fibers because they contain dash CONH linkage, but here in this polymer there is a ester linkage, that's why it is polyester. So these are the polymer formed by condensation process. So it is a polycondensation product of two monomers. One is terphthalic acid, that is benzene 1,4-dicarboxylic acid, and ethylene glycol, that is diol, ethane 1,2-diol. So it is manufactured by heating this mixture at 420 to 460 Kelvin in presence of zinc acetate and antimony trioxide, which is used as a catalyst. So this terylene or dacron fiber is obtained, and if you observe this, there is a dash O dash CO linkage, so it is a ester linkage, so that's why it is polyester. So this terylene is seize resistant, crease resistant, and it is used in blending with cotton and wool fibers, and also as a glass reinforcing material in safety helmet. It can also be used as a dimethyl terephthalate DMT. Then methanol molecule will be removed. Thank you for watching this. In next video, we'll discuss phenol, formaldehyde and related polymers such as bakelite, melamine, formaldehyde polymers, then some rubber polymers in detail, and some biodegradable polymers. If you like this video, you can subscribe and share my YouTube channel Mukesh. Thank you very much.